Okay. Oh god. My browser isn't sized right for this. There. Good. No, 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 no. Hopefully finish up chapter 3 today. No. I don't know why I'm looking back at these identities. It doesn't matter. We don't need identities. Wait. Yes, okay, chapter 3. Dude, I don't know why I never recognize the chapter that I'm on. No. Where did I leave off? I definitely did that. Did I skip over 61? I think I did. Okay, let me look at what pen center assigned. That'll be a better way to go about this. So wait, that one that I recognize is 60? Okay. So the next one was 62. Do I recognize 62? Yes. 65. Yes. 66. Yes. 67. Yes. I think that's where I ended. 68. Okay. Yeah, 68 is new. Alright, let G be a group of functions from R to R star. Wait. Oh no, I saw Pen Center do this one. I don't think I did it though. This one, it looks super weird, but it's actually not that hard from what I remember. Like with these weird group definitions, it seems like the key is to not get scared by the definition and just go through the steps of your subgroup test. Ooh, it's raining. So it is function multiplication, not composition, not addition. So G is a group of functions from R to R star. Okay, so H is all f and g such that f of 2 equals 1. So we're talking about, I was about to say that the identity function is f of x equals x, but that's the identity for composition. For function multiplication, I think our identity is still 1. So the identity of g is f of x equals 1, because you're multiplying by 1. Since f of 2 equals 1, the identity belongs to h as well. So h is non-empty. We get to name things that are inside h. So now we need to worry about closure. Let g and h belong to h, I guess. That means we know g of 2 is 1 and h of 2 is 1. And you can just see that when you multiply them, you still get 1, but I kind of want to, like, the way that makes sense to me to express this is like, let u, we don't really know, I mean, we can just name the input as x, I guess. Or let u equals g times h. U of 2 is equal to g of 2 times h of 2, which is equal to 1 times 1, which equals 1. So that means u belongs to h, and h is closed. I kind of like naming a third function for this, even though it's probably naming more things than we strictly need. So now we need to worry about inverses. So the multiplicative inverse is 1 over whatever your thing is. So we'll examine g. G inverse is equal to 1 over g. I feel like it's too dark in here. I'm just going to turn the light on. I don't know. That's a new alert. Zach, thanks so much. I was actually just about to turn the light on. Welcome in, everyone. Yeehaw! Okay. It's cloudy and rainy out, which I love, but it also means I have to turn my lights on. It's a you, Wadanio. Hey, Stookie. Yeah, it is peach tea. Thank you for the raid, though, Zach. That the differential equation was really like challenging. It looks so separable to me, and I kept trying to separate it, but just like didn't work. So I'm glad that Bluebird found the actual technique there. Yeah, for now I'm just doing my usual like filler thing of going through the abstract algebra textbook from Penn Center's reading group. Hey, Cold Gold. So I'm getting towards the end of chapter 3 here. I'm on 68, and I think for the ones that Penn Center assigned, we got like 4 or 5 more, and then that's the end of chapter 3 there, so. Gotta get lean set up then. Oh, yeah, because you said you wanted to do some of these proofs in lean, right? Oh, yeah, that was the D right there. So it's almost exact, and the way you can make it exact is multiplying through by 1 over y squared. Hey, SG1, how's it going? All right, so I'm working on 68 right now. I have proven that the identity is in H. I've proven that H is closed, and I have the idea for the inverses. I just need to actually like write it out. Great, that's good to hear, SG1. So I'm saying that G inverse is equal to 1 over G. And like, I know that G of 2 is 1 and that 1 over 1 is 1. I'm just trying to figure out like how I want to state that best. I guess I'll say like G inverse of 2 is equal to 1 over G of 2, which equals 1 over 1, which equals 1. So G inverse belongs to H. I don't know why I put a period there when I didn't write a sentence before it, but sue me. And then there is that very last part of the question, which is, can 2 be replaced by any real number? Which I don't see why not. The input didn't actually really matter. The output, though, is maybe the more interesting question to me. And if it's not 1, I think you have issues with basically any other number, because you wouldn't be closed. Yeah, okay. Next one on the list is going to be 69. Let's go. All right. You know, I remember looking at this one just for the memes, and I felt like I got the idea like as soon as I looked at it. Oh yeah, this one isn't closed. Solving for x in terms of y. Oh yeah, I didn't catch the entire discussion, so I don't know if they tried that method. So yeah, let's just give a counterexample for 69. Or wait, I'm sorry, it is closed. It doesn't have inverses. I don't know what I'm doing. Galahad Circus, thanks for the follow. All right, so let's say A is equal to 2003. A clearly, we're calling it H, right? Yeah. Welcome in, Galahad. How's it going today? Now let's take the inverse of A. And the trick here is that you do 1 over AD minus BC, which is 1 over 6. You switch those two corners. Oh wait, did I choose a terrible example? No, I'm good. You switch the two corners and negate the other two. And this becomes 1/2, 0, 0, 1/3, and that does not belong to H. So not every element of H has an inverse. Because, I mean, I guess it isn't really like... We were talking about matrix multiplication, right? Hey, Thunder. Yeah, multiplication. I feel like this should be good enough as a proof because we know in GL this is the inverse of a matrix. So it's not like there's going to be some other thing in H that is an inverse. Like if A does have an inverse, it's going to be this and nothing else. Which I think, yeah, we can just say that we know that from how GL works rather than having to go down a formal proof. Chord. What's next? 70. Got some complex numbers, okay. I remember seeing Pen Center, actually I remember seeing Pen Center do, I think I was watching Pen Center stream for this section of the questions. I remember this one not being closed. Because someone gave a really like clean example of 1 for your first number and -I for your second number. Where 1 as a complex number does fit in H, -I as a complex number fits in H. But you get opposite signs for your A and B after you add them. I'm not even going to try to pronounce that, but person over on YouTube, let's see. You only answer college math questions, right? You actually have some math problems in 10th grade. Oh no, I'm happy to answer any question that I can help with. So if it's 10th grade, I can almost certainly do it unless you're doing something weird. But please feel free to post your question. I mean, as long as I know how to help, I will absolutely help. I don't care how basic it might seem. So you can type it out there in chat, or I have a Discord server where you can post it as well, if it's easy to do like a screenshot or something. Dude, this bot is so slow. There we go. And while I wait to hear from you, I'll keep working through these like practice problems, but as soon as you type your question, I'll switch over. 71 is let H. Okay, so basically every complex number with magnitude equal to 1, or modulus, whatever you call it for a complex number. Well, the elements are going to be a circle, or like, you know, all the points that make a circle of radius 1 in the complex plane. Well, is it a semicircle or a full circle? I think a full circle. Wait, am I even right about this? Yeah, it's going to be the unit circle. Oh, that first has been up for grabs. Jeez, I'm 23 minutes in. People are slacking. Nice job, though, Zach. How many firsts do you have, actually? You've been getting a fair few recently. 3? Okay. I still need to make a leaderboard for that. Shoot, there's some people, like, how many does Jed have? 14, and Spetri has a good amount, too. I just heard a Mario sound. 20? Jeez, all right. Anyway. You only have what? Oh, I didn't start. Oh my God, Thunder, you should have way more. I think I didn't start tracking them when you were on your tear of getting first. Yeah, there was a good streak where you were just cleaning house. This song was just using a bunch of Mario sounds. Hey, integration by parts. Partial fractions? For what? In person over YouTube's name, I still don't feel brave enough to pronounce. I don't see anything from you yet, but I'm happy to switch over as soon as I see your problem. Oh, Cedar Prince. Yeah, no, it's just the radio that I'm listening to. I think it has a lot of like game music remixes and things like that. So, hey, Yanis. So like saying it, okay, fair enough. That's like a jump scare for me though. I'm doing good though. How about you? In Cedar Prince, I was lurking on your stream for a bit. It's kind of like flipping between a few streams, so I wasn't able to really get a good grasp of what you were working on though. Thunder, this is not homework. It's Penn Center's doing an abstract algebra reading group. I'm on page 96. So yeah, Penn Center's doing a reading group on this textbook. And I've been kind of like reading along, using it as like the filler for when there aren't questions from chat. Yeah, I did. I meant to pop in your chat and ask, but like I feel like I've heard you mention category theory or something at some point. I'm just asking because I know one person particularly who would probably be interested in talking about category theory that I could tell them about. The calculus of relations and experiencing with the light and dark side of the force. That is appropriate. It's May 4th. Hopefully, even though it was brutal, hopefully you still got something out of it, though. I'm supposed to do 71, right? Let me see what Penn Center said. Yeah, actually, I don't know what calculus of relations is. I've heard of calculations variations. I don't know what it is, but at least I've heard of it. Calculus of relations. I don't know. Okay, 71 is on the list. So yeah, I said this would be the unit circle. Ian Stuckey's here, really a full circle moment for you. I mean, yeah, I know how to look up the Wikipedia article. I've done before. It's not the kind of thing that I remember. Because I know I've looked up a calculus of variations as before, but I just as soon as I close out of the page, I forget again. So that's been being a distraction. Oh no, I am happy to have distractions, especially like if someone comes in chat asking an actual like math question, then I'll like focus on that. But if I'm just doing other stuff, then I don't care. If you want to see something crazy, in this paper on page 6 is what I was talking about with the light side and dark side. Okay. Yeah, either type them out in chat or put them in Discord. I'm gonna warn you, if you're gonna submit a question for fun, I reserve the right not to do it. But if it's a homework question, I'll obviously like try my best. And if it's a for fun question, if I don't have anything else, then I always like try to think about it. But people tend to ask things that are hopelessly out of my depth that I just can't really do anything with. Oh gosh, there aren't page numbers on the actual pages. Page 6. These look like circuits. You want to spend 90 minutes solving a D? I mean, for that one, that actually like kind of held my interest. Some people like want to talk about things that are great, but just I know nothing about and I don't find all that interesting. I have no idea what any of this means. Cartesian bicategories. Co-Cartesian bicategories. I don't... Okay, yeah, so I'm glad that someone can make sense of this, because I recognize that these are words in the English language, and that's about as far as I've gotten. You read the star, right? Oh, okay. Never mind, I guess. You submitted homework question, something. Oh, okay. Yeah, sorry, I never know what to expect when someone has a name related to math. Sometimes they're like some super math enthusiasts who are studying very advanced things. That's why I'm a little like cautious when someone just like asks, "Oh, can I ask a question?" Okay, fair enough. I think they're English words. Yeah. I'm like 60% sure these are English words. No longer a teen, Jed. Nice. You're in your 20s. Okay, so we have h of x equals 4x cubed minus 19x squared plus 28x minus 4 over x minus 2 squared for x is greater than 2. Right, h of x. Oh, it's one of these. I would do division, I guess. You tried synthetic division twice and it didn't work. GLHF? Oh no. Is long division that bad with this? I guess let's try it. I'll find out the hard way. You love partial Thunder. You're not allowed to love partial fractions. Partial fractions are the devil. I don't think I've met anyone like who likes partial fractions. Those should be banned words. The devil's staircase is the devil. You're allowed to like partial fractions. I just didn't know anyone actually liked that, I guess. But for this, like, I would do division. Like, I think you only do partial fractions when the degree on top is less than. Like, this to me looks more like division. 4x cubed minus 19, wait. Okay, yeah, x squared minus 28x. Is that minus 4? Wait, it's plus 28x. Oh my gosh. X minus 2 squared. Calculus yes, partial fractions no. Hard agree. You do like continued fractions though. Oh, I have a very difficult time working with those. I don't know the tricks, but those have some neat like properties. Let me just make sure the picture's a little blurry, so I want to make sure I copied it down right. I think I got it though. Okay, so I'm going to expand out the bottom. This isn't factorable. No, that sure is not factorable. X squared minus 4x. plus 4? Okay. Now I'm going to do long division. I mean, synthetic division should theoretically work too. I never remember how to do synthetic division. It's too much memorization for me. Okay, so if we do the long division, we're gonna start over here. We want. Wait, sorry, we're gonna make a linear term here, but we have to make x squared match 4x cubed. So we're gonna say 4x. So 4x times 4x cubed becomes 4x 4x times x squared becomes 4x cubed, just like what we want to get that cancellation. Now everything else, just let the chips fall where they may. So 4x times minus 4x is minus 16x squared. 4x times positive 4x. Ignore the words that I'm saying out of my mouth. Just, I haven't been able to speak this entire week, I feel like. Minus 3x squared. I don't know why it's been such a struggle for me. 28 minus 16 is 12. Negative 4 just comes right down. Now we want to make the x squared match minus 3x squared. So let's multiply through by negative 3. So we get negative 3x squared from that and that. Negative 3 times negative 4x is plus 12x. Negative 3 times positive 4 is minus 12. Interestingly, the 12x's go away here. Negative 4 minus negative 12 is 8. So our remainder is 8 over whatever the original thing was. And I'm going to rewrite that as back to x minus 2 squared. So I think that's our answer for part A here. Was it a question critical? Sure, I'll take a look at it after. So integration by parts, are you good with this so far? I can try to do the synthetic division way as well, if you want to see that. I just have to look up how it works again. It's that long division, I feel safer doing it the correct way. I feel like with synthetic division, I'm likely to make a mistake. I'm happy to do it if that's the way that you prefer, though. You know, you don't really know how to do it? Oh, let me explain it better. Or if you'd rather just see the synthetic division way, I can do that too. But the long division way is, I kind of want to work back through this now. I would say it's like normal long division when you have just like a number and a number. It just looks crazier, and you have to do a little bit of, or it is a little bit like trickier, but the principle is kind of the same. Except you more look at the leading coefficients, and you do whatever it takes to make this leading coefficient on the outside match whatever your leading coefficient is here. So if you want to make x squared into 4x cubed, we need to multiply this x squared by 4x. So I put the 4x up here, then I took it and multiplied through by the entire thing and subtracted it out. So the 4x cubes cancel, and then for the rest of that, like, I just kind of let the chips fall where they may. Like, we'll deal with whatever we get from the result of this subtraction in the next step. So I did 19 minus negative 16x cubed, and 28x minus 16x. And now our new leading coefficient is negative 3x, because negative 19 minus negative 16x squared. So then we do whatever it takes to make this x squared match the negative 3x squared, which is multiplying everything through by negative 3. So that's why I put the negative 3 up there, multiplied it through, and then I put the result down there. When you multiply it through by negative 3, you subtract it out again. But I feel like I should just do it the synthetic division way. If that's what you're more comfortable with. I'm happy to try to explain it more too. But if you're using synthetic division and it generally works for you, I want to like do the thing that makes sense for you. I'm just okay, so there's already a tricky bit when x equals 1. Like you have to flip the sign. You take it down, multiply it by that, and you add down the column. The last carry down is the remainder. Guide you through it? Okay. So let's erase this. We should get the same answer. And Thunder, I saw you posted something as well. I'll take a look at it in a minute. Although Critical also posted a question, so I'll see whichever one is shorter. Okay, so if we do synthetic division, I guess we prefer it in the original form because it's in the form x minus 2 squared. So let's we take 2. I think I was taught to like put it in a box like that, and then we put the coefficients. Then we have a line there. So we drop the 4 down just as it is. And then we do 2 times 4 is 8 and add down -11. Then 12 and then 8. So we interpret this. We take the powers from up here and like move them all down by 1. So instead of x cubed, we're now going to have x squared. 4x squared minus 11x plus 6, and then the remainder 8. Is that going to be 8 over x minus 2 squared? Oh, and that's all over x minus 2, I think. I think that's how this works. Evil Don come only 500 points left. Oh, get hyped. You write the coefficients of the numerator divided by the answer of the denominators. Okay, I think I set this up right. Yeah, so synthetic division, you can only do it like 1 term at a time. So then this is where you have to do it for the second round. I think that's the downside of synthetic division, is that it's technically less flexible in that respect. Yeah, so let me like follow the second stage of synthetic division through to make sure that we get an answer that matches what I got before. But I think this is the technique. So now we're doing just this block of the division with synthetic. 4, 8, -3, -6, remainder 0. Okay, so this means we take these powers from up here, slide them all down by 1, so we get 4x minus 3, no remainder, so let's carry over this other remainder. Oh, hey, look, it actually matches. So yeah, the thing to remember with synthetic division, I guess, is when you have multiple factors in the denominator, you have to do them one at a time. So in this case, we have x minus 2 squared, so you have to do this division twice. And the remainder bit can be a little bit tricky, but as long as you're careful, you can get the same answer. Oh, sure. Tell me when you're good. And do you want to see part B, or do you only need to see that part? You're good? Okay. Part B is simple? Okay, sounds good. Oh yeah, it's just a U sub for the denominator part. Okay, so Sick Ian Suki put a preliminary answer to Thunder's question. Yeah. I thought I was getting my names mixed up for a second. And then critical is asking a solves a revolution question. So I'm gonna look at Thunder's question first. I think it'll be a little shorter. If x equals cosecant of 5y, what is dy dx in terms of x? My question is, why do you take the positive square root? So this will be finding the derivative of inverse cosecant. Maybe this won't be shorter. On IBS? Integration by substitution? Oh yeah, I mean, okay, I was thinking of like irritable bowel syndrome. But yeah, okay. Do a chain rule. Yeah, I mean, for a simple sub like that, I just think of it as the reverse chain rule. And I think for even for x minus 2 squared, you don't really even get anything meaningful out of the sub. You can just kind of integrate it like it's normal. Yeah, I'm gonna do the solves of revolution first, I guess, because I thought that was just gonna be a quicker question, but if I need to actually work through the derivative inverse cosecant, that's gonna be a minute. Yeah, so even if you don't write the u-sub, you're technically like doing a u-sub, you just aren't writing it. So we have the curve y equals 2 root x from 1 is less than x is less than 2, rotate about the x-axis. Okay. So critical. Thankfully, this actually isn't. These solves revolutions questions get kind of crazy, but thankfully here we still have one curve to worry about. No worries, integration by parts. Thanks for the question. If you encounter more, please feel free to keep them coming too. So I noticed here you posted your attempts, which I really appreciate. Oh, it's okay. Never mind. So this is something that you were given. I was just about to wonder why we would want it in this form. It's not given. It was there. So all this is rearranging the initial equation. So you divide by 2 and square each side. I would kind of keep it in the original form, though. Is there from the person's note? Because, I mean, let me make sure I'm not going to tell you the wrong thing here, but... Well, okay, so there's two, like, basic methods, which are cylindrical shells and disks, I think are the names. And to me, disks seems easier, and you would leave it in X. Do you do any Boolean algebra? I learned it a while ago. I might be able to remember it if you have a problem. Like I'm talking about like truth tables and stuff like that. It's going to be after this question from Critical and then after the question from Thunder, but I don't mind trying, or at least seeing if I can remember it. These two things are basically the same statement. There's like a little like technicality, but these are basically the same statement. Like you are allowed to do these rearrangements. There's nothing invalid about this as long as you know like what you've done. I think this problem is easier. Yeah, sure. I can show you how to do that rearrangement. I think the problem is going to be easier if you leave it in the form that you're given, though. But I'll show you how to do the rearrangement. There's multiple ways to go about this. But yeah, like knowing how to do that rearrangement, like even if I don't think it's helpful for this particular problem, you should know how to do rearrangements like this, because you definitely sometimes do need to rearrange. You definitely sometimes you need to be able to rearrange things for some types of solid resolution problems like that. So if you're not comfortable doing that, I definitely want to show you how you do it in this problem. So the first part of your question here is, we started with y equals 2 root x, and we wanted to know, this is solved for y in terms of x. And if we want the other version, which is solving for x in terms of y, how do we do that? Wait, I messed this up. It's 2 root x. Yeah, thank you. So if we want to solve it for x in terms of y, that means we want to isolate x. So the first thing that's in the way is this 2, so let's divide each side by 2. I write it as 1/2 y equals root x. You could write it as y over 2 as well, it's the same thing, it doesn't actually matter. And now the last thing to do to isolate x is to get rid of the square root, and we get rid of the square root by squaring each side. So it's 1/2 y squared equals square root of x squared. So the squared and the square root, there's a technicality here, but I'm just going to say that they cancel. And we have 1/2 y squared. Each of these gets squared individually. 1/2 squared is 1/4. And y squared is y squared. So that's how that rearrangement actually works. Does that make sense to you? Yes? Okay, cool. So I'm saying that I might rather leave it in this form up here, because this is really going to lend itself to the disk method. And how the disk method works is, I'm going to just very roughly, well, I mean, we can draw 2 root x exactly, can't we? It starts at 0. Well, I'm not going to draw it exactly, who cares? It's a parabola, but facing sideways, or it opens to the right, and we only draw the upper half. If you don't know, like, root x is just a good one to just know, but you can think of it as, if a parabola is x squared, this sideways parabola is root x. And our interval is between 1 and 2. Oh, sorry, yeah, I was assuming you want to see the entire problem as well, so I'm glad I'm already, like, going into it. So what's happening here is we want to rotate this section of the parabola around the x-axis. So it's going to be almost like a dome with the top cut off, where like this is the top of the dome where it gets cut off, and that's the bottom of the dome. I don't know if that visualization is even helpful in the first place, but the idea here is that this solid is, like, this sideways parabola is the edge of the solid, whatever shape it may be. So we're taking this edge and bringing it all the way around the x-axis and back up around on itself. And each of these circles has area pi r squared, and r, the radius, is just the distance from the x-axis up to the parabola here. And that's how I remember the disk method, because that's it can get more complicated, but that's fundamentally all that's happening. So when we go to set up the integral, we're taking, infinitely many circles between 1 and 2. And we do that with integration. So we have pi still times our radius squared, and our radius is 2 root x. Oh my god, I was about to write root 2x again. From the bounds that they give us, 1 to 2 dx. And once we do this integral, we have our answer. You can technically do this with cylindrical shells as well. I think it's needlessly complicated, though. Is just me, is video not synced? Oh no. I hope it's synced. Here, I'll clap. I don't know. If it's out of sync, then I might be able to fix it, but it's synced. Okay, cool. I hope that clap wasn't too loud. By the way, maybe I did it too close to the mic. Yeah, so it's not rectangles. It's as for this interpretation, we're not thinking about a Riemann sum. So it's integral 2 pi y square root. That formula is something else, I think. That's for like the surface area of the solid revolution. Oh, I should read the question. The question was the surface area. Oh my god, I'm so sorry, Critical. I thought it was, I saw a word that starts with S, and I was like, oh, that's clearly solid. Oh my god. How does this work again? I think surface area is usually a little simpler. They don't give you as crazy of problems for these. Oh, I can't believe I did that. Okay. We're rotating about the x-axis. Two pi y square root. We're gonna want. I'm not in love with the way that Paul's notes presents the formulas here, so let me just rewrite it. It makes you do a lot of like mental visualization for what the formulas you actually need are. If we're rotating about the x-axis, I mean, I can't believe I did that. The formula we want to rotate about the x-axis is 2 pi x1, x2, y, which remember is a function of x, so we're going to plug in this formula here for y, times square root 1 plus dy dx squared dx. So we're rotating about the x-axis, everything's going to be in terms of x, but the formula involves y just because that's how it's presented. Let me make sure about the x-axis. I lost all confidence now. About the x-axis. I know the screen capture is messed up, but yeah. So I'm really not sure then. I'm making goober mistakes. Yeah. So I'm really not sure why this rearrangement was happening in the first place. Then I'm getting a little worried they're doing something wrong, but I'm pretty sure like this is the formula that we want. Y is 2 root x. Dy by dx deriving that, you get 2, that 2 just stays the same. Root x is the same as x to the power 1/2. Applying the power rule to that, you get 1/2 times x to the minus 1/2. So 2 and the 1/2 cancel. And the same thing as 1 over root x, and I'll rationalize, because why not, to get root x over x. Oh wait, let's not do that. We're gonna square it anyway, because you have a dx squared, so 1 over root x squared is 1 over x. Oh, how do you do this? I guess you multiply the x in. But before I even think about actually integrating this, I hope this makes sense. Critical? Because you put in the other version of the formula, or actually I guess you kind of mix the two versions of the formulas. Okay. So if I'll go through this integration, I'm going to bring the 2 out front to make it 4 pi. And when I have a square root times a square root, so let's make them share a square root because that's allowed by properties of exponents. And now let's make the integral a lot simpler when we multiply the x inside in the next step. X plus 1 dx. Now we can just do this with a u sub. U equals x plus 1. Du is dx. So we get equal to 4 pi. I'm just going to leave off the bounds for now and not put them in terms of u. But that's a preference thing. So just get root u du. We know how to integrate root u. It's you add 1 to the exponent, you divide by the new exponent. Our current exponent is 1/2. You add 1 to it, you get 3 over 2. When you divide by 3 over 2, you multiply by 2/3. Now let's unsub and plug in our bounds. X plus 1 to the 3 over 2. Evaluate it from 1 to 2. 4 pi 2/3. 3 to the 3 over 2 minus 2/3 times 2 to the 3 over 2. Ew. I kind of hate it. I mean, we can factor the 2/3 out. 8 pi over 3. 3 to the 3 over 2 is 3 root 3 minus 2 root 2. So technically we could say that the answer is 8 pi 3 root 3 minus 2 root 2 over 3. I'm not a big fan of it, but I guess that's what we get. Yeah, critical. I was kind of like, I was wondering why that was given, or why that was a part of the setup here. I don't think you need to rearrange it for y. Like this arrangement down here, I don't think you need it. You're only allowed to take out constants that are multiplied. Yeah, sorry, I said it wasn't given, but wherever this did come from, it doesn't, like if you're rotating about the x-axis, your integral is in terms of x. Okay, I'll look up a second source just to be safe. I think it's because, I'm going to say something wrong here, but I think integrals are what's called a linear operator, and any linear operator means you get to take out coefficients. It's all by the same thing. You get to, if you have the integral of two things added, you can integrate them individually for the same reason. Now, why does the linear operator do that? I don't know, but okay, this gives me some confidence. So the surface area S generated by revolving the curve y equals f of x about the x-axis is defined by this formula here, or this one. They're both the same thing. So if you're rotating about the x-axis for surface area, you keep your integral in terms of x. So I think I'm right. I'm not a big fan, like the answer looks a little ugly, but it depends on the question they ask you. For surface area of revolution, if it's x-axis, your integral is x. Or if it's x-axis, you want to integrate in terms of x. If it's y-axis, you want to rearrange and integrate in terms of y. So if you had the same problem but rotated around the y-axis instead, I would say this is the helpful thing. No worries. Let me bring up Thunder's problem. Oh, thank you for copying. I was just doing that too. If x equals cosecant 5y, what is dy dx in terms of x? Why do you take the positive square root? Yeah, how do you restrict the domain for cosecant? Cosecant is the inverse of sine. I wonder if you do the same restriction. Yeah, that's something like how you would prove it in the way that Thunder is supposed to, but it's kind of a question of like once you do that, there's a certain step we have to decide between plus and minus. Oh, really? The bounds are flipped for arc cosecant to arc sine. How does that work? I want to look at how this thing is, like, what is a graph of? I don't think I've ever looked at the actual graph of it. Yeah. I definitely want to like answer that. I'm just trying to wrap my head. Whoa, what is that? Oh, I get it. Graph cheating. Yeah. Okay, so I see what's happening to the graph now. Where you're basically taking the left half of this blue curve and reflecting it across y equals x, and you're taking the right half of this part of the blue curve and reflecting it the same way. I guess that's good enough. Can get this on our calculator these days? Okay, so yeah, this one, it doesn't. Okay, so I remember you saying, well, do you know how cosecant looks? Like the graph of cosecant? Because actually, this is making me think we need to take the negative. Unless I'm thinking about the wrong part of the graph. Oh, I'm thinking about the wrong part of the graph. We're not taking that part. We're taking this part. Because I remember, God, this is hard to work through, to be honest. So, I remember you saying a trick with, like with arcsine, like we know it's increasing, so let's just take the positive. The same trick does apply here, it's just harder to see. Yeah, the gradient. Because like on this section of the curve, it's increasing up until x equals 1, but that's good because that's our cutoff for the domain anyway. Or sorry, -1. And then over here, we go from x equals +1 to infinity, which I don't know how that works with the periodicity. That part is kind of confusing me, but over here, like this section of the curve is always increasing as well. Like I kind of want to work through the derivative for myself too and see if I can think of a different justification that's not as tricky. Isn't the restricted domain cosecant x? Well, so your next problem was x equals cosecant 5y, finding the derivative. I assume the point of the problem was to find the derivative of arc. Oh, okay. No, thunder here, not. So that same trick with the derivatives works. I wonder if I can think of a different way to justify it too that's not reliant on the graph, because I definitely would not, like, without the benefit of Desmos, I would have been way less sure of saying that. So, I mean, if you're good, I can just leave the problem here, but I feel like I haven't really given it a good answer for if you don't have a graphing calculator. Unless you're just really good with the domain restrictions of the inverse trig functions. I can remember it now that it's just the opposite of the domain restriction for sine. Any alternative way? Yeah, exactly that, Thunder. If in doubt, use trapezium rule. I've never heard of that one. All right, yeah, so let's see if we can find a non-graphing way. So it's the original problem would have been y equals 1/5 cosecant x. And we want to find dy dx. Sorry, arc cosecant. One plus cotangent squared 5. What? I don't see where that's coming from. It might be right. I just I don't see it yet. So we'll start by finding dx dy. Yeah, so I know where the identity comes from, but we have just cosecant. Like we would need a square root around all that, don't we? You differentiate. Okay, let me, I guess, differentiate then. Okay. Yeah, who the heck knows what the derivative of cosecant is? Trig derivatives. It's probably like negative cosecant cotangent. That's my guess. Oh, bam! Negative cosecant cotangent. You've been oh, okay. Well, Phobos knows, but we can't all be as good at math as Phobos. So we get negative 5 cosecant 5y cotangent 5y. Hopefully I wasn't too incredibly stupid there. dx, yeah, that's what. I think we're good. I mean, we could technically do it implicit differentiation. I kind of prefer that. I mean, we can do whatever way you prefer, though, Thunder. Let me look at what. Thunder also knows I'm sleeping on the math. Dude, no, I absolutely am sleeping on that. This way is good? Okay. I mean, yeah, it's all the same, so we'll have to flip it anyway, and it's the same as doing dy dx. So yeah, I guess I see what you're saying. So the Pythagorean identity that we want here, 1 plus cotangent squared is cosecant squared. So off to the side, 1 plus cotangent squared x is cosecant squared x. So we can apply it, I guess, on the cotangent. Oh yeah, so that's where, is this where we're wondering if we want the positive or the negative square root? Because that's a good question right there. Precisely, okay. Okay. This is earlier in the problem than I thought we would encounter it. So, okay. I can see why we take the the positive part, because we already had the negative, like based off the graphical like thing that we did before, we are expecting a positive result. Or sorry, a negative result. So we want to take the positive one to keep that negative sign intact. But of course, if we don't know the graph, how can we work that out? I'm trying to think if there's something we can do based off how it works for sine. Because sine and cosecant are definitely related. Please inverse functions idk while you take the positive. I don't know. If there is a universal reason why, I'd love to hear it. I assume you have to tailor it to each problem, though. I mean, usually in general, people just take the positive and don't worry about it too much, but that's not really, like, right. I mean, well... If you did take the negative, would you have another valid definition for the derivative of arc cosecant, just on a different domain? I don't think so. I feel like if you take the negative case, you get something invalid. I feel like there's some kind of right triangle that we could probably make here, right? maybe not. Can we think about like test points maybe? Cosecant squared 5y equals x squared? You're talking about squaring each side of that? I'm not sure what that does for us. Would that avoid the... I mean, I guess it would kick the can down the road if we want to square each side here and then derive. I think we're still going to have to make that decision pretty quick, though. No, no? Oh, I'm not sure what you're saying then. Maybe the graphical method is the best, but we can work it out by hand. So why can't we take the two inside parts here? Like if I wanted to make our cosecant with just that part and just that part, like what's the issue? If you reflect that piece across y equals x, what's that point? It'll get reflected. Yeah, it's not 1, 1. You'd have like that. I guess there would be a horizontal asymptote for no matter how we do it. That would be like that. Why isn't this valid? Did I reflect it right? I might have reflected it wrong. If we're reflecting across that line, no. This is... Okay, wait. If cosecant... the domain is all real numbers except n pi over 2, where n is an integer. The reflection's wrong? Okay. And I think Pope was probably saying the same idea. Let me... I want to think about the domain and range just like a bit before I go back to Desmos. Oh man, this place already looped. Let's go over to this song and do radio on that. The range is 1, infinity union -1 infinity. Oh my god, parentheses, not brackets. So the arc cosecant flips the domain and range. So we do have the horizontal asymptotes. And I guess we want arc cosecant... I guess they're... Okay, fine. Let's go to Desmos. Cosecant squared x instead of x squared? Oh, you mean in Thunder's message. Ooh. No, it's not Fortnite music. Does Fortnite have music like this? The song is Kaiju by Radar. Cotangent x. Yeah, I was looking at what you were saying. Cotangent x is square root. Sounds similar to Fortnite. Oh, okay. Oh, are you saying we don't have to worry about Pythagorean identity? We just do we just simplify cosecant of arc cosecant and cotangent of arc cosecant? I would prefer that way. Does that work? If we just remember at this stage what y is? I think that's probably better. I like that a lot more. Because I like trying to work out the graphical explanation by hand is terrible. For me at least. I would much rather... Yeah, I forgot. I mean, that's how I like to do it for arcsine as well. Like, just do the right triangle stuff. Like, we know that y is 1/5 arc cosecant x, so let's just plug it in. I'm also going to flip each side. dy dx is minus 1/5 csc 5 times 1/5 arc csc x cotangent arc cosecant x. So much rating. Cosecant. Is this gonna work? So find out the hard way. 5 cosecant of arc cosecant of x is x. And then cotangent of arc cosecant, we need to draw a right triangle for, right? Or is to have my arc cosecant is just an angle. We can take cotangent of an angle. Cosecant. Oh my god, it's 1 over sine. Sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. Pythagorean theorem. Maybe you just always take the positive because of this Pythagorean theorem thing. You're talking about a distance? No, it's kind of weak. I think this is actually getting us the right answer. Like, this seems familiar. In the right triangle way makes it a lot clearer that it's a distance. Okay, this does match, except it's the absolute value of x. Let him cook. So wait, the question is x equals cosecant 5y? Wait. Fish? I was just checking the time. I'm still good though. How's it going? IffyQ? Yeah, I mean, this isn't, we're trying to find a derivative. I think I misunderstood the question though. X squared equals cosecant. Wait, so so Thunder, I assume the question was to find the derivative of arc cosecant. And you just kind of gave me the first step with making it x equals cosecant 5y. Is the question something else? Because I don't know what's happening with the squaring each side thing. Okay, well, find dy dx. Okay, so that's still basically the same thing. I think I found dy dx. You can square each side? Okay, if we're supposed to square each side, I guess we can do that. And sub it back in. What? X squared equals cosecant squared 5y and cotangent. Let me look back at the work. Where I wrote cotangent x. Oh, well, I guess so. I just realized I wrote the problems coming up the identity part, but who cares? So yeah, if I said 1 plus cotangent squared 5y to match the problem, cosecant squared 5y. We do know that cosecant of 5y is equal to x, so cosecant squared of 5y is equal to x squared. I think we still have the same problem though. With the plus or minus square root, like who the heck knows what's happening? Like, I don't think this is substantially different from... I think this is getting needlessly fancy if you want to sub out the cotangent. You can do it. I have a hard time justifying from here. Like, I feel like it's still the same plus or minus issue. And maybe that's what Phobos is saying, like, to graph it. Okay. So, I think it's a lot more direct. Like, at this stage, you just remember that y is 1/5 arc cosecant x. I think it's a lot more direct. There probably is some justification still to decide between the plus and minus. I'm just having a really hard time coming up with it. Yeah. Why aren't you taking the negative when you square cotangent squared? Yeah, I'm not sure. Like, it seems like Phoebe was able to come up with a reason based off the graph, but I don't really see it, I guess. Cotangent x is decreasing or increasing. I think I've worked out how to do the graphical method by hand, but this Pythagorean identity thing, I have no clue. My favorite way really is like what I wrote on the board on the right side of the whiteboard. Trying to do it this other way, I don't know. Yeah. So, I think it's something I'll let you know, but I'm not sure I'm not sure what else to do with it so far. Integration by parts. Did post this question earlier. It looks like, I assume this is integration by parts' question. So let's take a look at it because I spent a bit of time on that. The subject was floating point arithmetic, which I did learn at some point. The computer represents a floating point binary numbers using 6-bit mantissa and 4-bit exponent. And the mantissa is basically the number itself without any decimals in scientific notation, I believe. Add the following three numbers together and give the answer in the form described. You must show working. Make sure that I'm right on that, though. The most significant bit is always 1, true, because of scientific notation. Times 2 to the scientific notation in base 2. You are here. Integrate your hearts. Okay, good. Sorry for the wait there. We're taking all of these as positive, I think. IEEE 754 time. Is this the standard for it, Phobos? You probably remember this better than I do. It's been a minute since I've done this. Following the numbers give the answer in the form I described. That's floating point standard. Oh, okay. This is like some weird 10-bit stuff. Like, why would you want a 6-bit mantissa and a 4-bit exponent? That seems super weird. Oh, okay. Both using 2's complement. Wait, what does using 2's complement mean? I mean, I guess you do get more order of magnitude, but it just seems like it's some weird numbers. So if lengthy numbers can give both using 2, I feel like I could maybe work it out, but I'm worrying I'm going to do the wrong thing because I don't know what using 2's complement means. So like this number here, oh gosh, this is 2 squared. So this would be, so why isn't there a leading 1 on these? Like, shouldn't be 1 point? Oh, wait. Oh god. I feel stupid already. If you don't know it, I feel like I should know this. It's just trying to remember it. So I thought there's like a leading 1 that's implied here, or is that just maybe not the right context? Like we shouldn't be 1 0 1 0 1 0 0, and then you move the decimal, I guess, to the right twice. So I guess you also move the decimal to the right twice. So I guess we agree on that at least. That moves the decimal to the right once, and that's also twice. I think at the end you would have to translate it back into this 6-bit mantissa 4-bit form, or 4-bit exponent form. I'm trying to remember like how to check the actual math though. They just start using 2's complement without actually saying what 2's complement is. Huh. Send it to a classmate and watch them suffer. you see the question? Oh yeah. I feel like I have my idea of how to do this. I just can't say that I know I'm right. It's also posted in the Discord, but there you go if you want a screenshot. So, hey Fenbox. I think I agree with your process here, integration by parts, but I think the number is really like this should be yeah. So I mean, I'll give my opinion, and you I guess take it or leave it. And I would not blame you at all if you leave it. But this does match with what my memory of what the mantissa is, which is there's an implied leading one. And I don't think I saw that in your work. But if anything I'm saying sounds wrong, there's a good chance it is wrong. So I'm assuming these are all just like positive numbers. And if what's stored in memory is 0, 1, 0, 0 for the mantissa and 0, 0, 1, 0 for the exponent, I think you would translate this to be 1.010, like this entire thing with a leading 1 point in front of it, times 2. This is messy notation, right? Like, but and then I think you move this one to the right twice like that, and your actual number is that and then you then do addition like you did with this number instead for the first one. That's what I think it's supposed to be, but I'm too far out of my memory to be able to tell you confidently that that's what you're supposed to do. I'm gonna look up one more thing, but you don't have to take, or you don't have to like stick around and take my word on any. So I'm just kind of curious to see if I can remember this better. Floating point number addition. Eight bits allocated for the mantissa, 4 bits allocated for the exponent. So that's 4, that's another 4. Okay, so that's the mantissa. The last 4 are the exponent. No worries, integration by parts. Oh, am I wrong? This side is not doing what I did. I guess I'm just wrong. That's weird. Why don't you need to worry about the 1 in front? Maybe it actually doesn't matter. The 1 might not matter if you're putting it back into floating point anyway. Hmm. 0, 1, 0, 0, 0, 1, 1, 1, 1. What did you get? Hmm. Interesting. Maybe. Oh gosh. Okay, that's why I'm just exploring the problem for fun. I like. Don't feel obligated to like stick around and watch this because I'm just kind of interested in trying to remember this. But go away. Oh my god. Keep your cookies away from me. I never thought I'd say that in life. It's the first time those words have left my mouth. That's some crazy stuff. I'm a pie man. Yep. With 2's complement. Three coffee beans away. 3? Oh, I mean, I guess you do get coffee beans pretty quick. Big brain Dawn or evil Dawn? Oh god. I don't know. Why is this link so weird? Means flip and add 1. Really? I don't remember that at all. Like, do you... When they say both using 2's complement here, does that mean you have to do anything special with the numbers here? Although I guess if you're asking the question, you might not know the answer for certain. Or is that just like some kind of extra information? Rewrite the smaller number such that that's kind of the bit that's confusing you. Okay. Back to you in 3 to 5 business days. Your friend knows the play. I hope there's someone else is waiting to ask a question, by the way. I'll help you switch over if someone has a question that I can probably answer better. I actually kind of think that binary arithmetic is fun. I just don't remember it at all. They don't put unnecessary input in, so it's definitely necessary. Okay. This is a binary, though. So if we don't have a leading, oh, so maybe it just means that this last one is a negative number because it has the leading one. The others are positive. Hey, Anders. I'm struggling to remember floating point arithmetic. It's more just like for fun though, because there's no way in heck I can answer this question confidently, but it is a little Carpenter Brutish. But this song is At the Gates by Radars. I put my music player of choice, which definitely isn't Spotify, just onto the radio of a Radar song. Oh, Big Brain Dawn. All right. Let's put the floating point arithmetic down for a second. Big Brain Dawn. Ah. Let's see. You know, okay, let's make sure we have a clear canvas. I'm going to spray that thing down. Dang it. Okay. All right. How do I draw me with a big brain? Let's well, the bottom part of my face should be normal. Let's draw a little bigger. And then we need the big brain part up here. So I guess this is gonna look terrible. Oh my God. We're gonna have some, should the veins be red? Oh, I kind of, no. The veins will be blue. It looks like I got attacked by a knife or something. Maybe blue is gonna look equally as bad though. How do you draw like a eureka face? It's like, oh God, my eye is very slanted. Like, no, that looks like it's unsure. What if the eyebrow goes the other way? God, that it's terrible too. Oh wait, raised eyebrows maybe. No? Come on, the eyebrows are like the most important part here to me. Okay, that's better. I want to get rid of the eraser marks now. Got some big ol' eyes. Red veins? You want red veins? Red coffee eyes? Oh yeah, so integration by parts. I have a I have a channel points redeemed. So for 5,000 channel points, you can make me draw whatever you want. That's also safe on Twitch. And Thunder's been saving points for a long time to get me to draw me with a big brain. And the emote that Thunder and Anders both put in chat there is a previous drawing that Thunder had me do, which was a self-portrait of me upside down. In Bigula, yes, it's supposed to be me. So Thunder, if you want red veins, I will give you red veins. It's gonna look like I got cut, but you know. If it makes you happy. We will get the hair in there too, don't worry. But we gotta do it one step at a time. Well, I don't know if we'll do hair. Hair might look weird. But we'll definitely get the beard in there. Wait, when your eyes are all red, it's not that part of your eye isn't red. It's the other part of your eye that's red. I think I got that backwards. Definitely beard? Okay. Need glasses. Said as a joke, but even better. Yeah. Yeah, we'll get glasses in there. I drew the wrong part of my eyes as red though, right? It's the whites of your eyes that are red. I gotta tear down the eyes. Goodbye, eraser. No, okay, those eyes are too small though. It's fine. I have small eyes. And you know, this self-portrait needs to be super accurate. The people demand it. You know, this red also feels wrong in the eyes. I don't know. I can't remember how it's supposed to look, I guess. We can have... What color are my glasses? I think they're just black, aren't they? I guess so. Okay. Need glasses? Haven't slept in 5 days? Oh, wait. It's about me? Pigula? Yeah, it does look like that. If you haven't slept in 5 days, then I apologize. Even though it's not my fault, I guess, but... That would definitely suck. How do I... I guess I need ears. That's an ear, right? Okay, you know, this isn't too bad so far. Should I have a stupid smile on my face? Experienced water eater, hey. Fight Club reference? I'm definitely doing math right now. Don't worry. Speed of weird occurrence for new viewers. Yeah, no, this is the perfect introduction to my channel here. So I'll take a quick break from the drawing. Quit math, become an artist. So I have a bachelor's in applied math. I can help with things, especially that are like calculus and below. If you want to call that, it's like I'll do anything like from like fractions in like single variable algebra all the way up to calculus. There's some things that I know like that are a little bit beyond calculus, like linear algebra and differential equations a bit. But after that, my knowledge starts to get a little fuzzy at best. But if you have a problem that's a bit too advanced for me, there's often someone in chat who does know the answer, depending on the subject. So, yeah, if you have a question, please feel free to type it out in chat or put it in the Discord. And if you're just here to chill, that's completely fine too. What's pointy smile and bolder glasses? Okay. What's happening? Wait, I thought you wanted big brain. Oh, okay, yeah. So what's happening right now is I have a channel points redeem to make people, or where people can make me draw something. And so Thunderfix there is making me draw myself with a big brain. But apparently I'm supposed to also be evil. So that's news to me. I just noticed that the glare is covering the picture. That kind of sucks. Sharper jawline? Okay, so less pointy smile, bolder glasses. You're right, I didn't draw the actual lenses in there for sure. Man, the black marker's kind of dying on me. Thanks for the follow. Oh yeah, why do we? That sure sounds like a homework problem. Integration by parts. All right, sounds good. I'm gonna keep on thinking about your problem. If I can get anything that I feel confident in saying, I'll get back to you in Discord. But yeah, thanks so much for hanging out and for the questions. Yeah, Thunder and McGill, that's Fermat's last theorem right there. It is proven, but like the dude who proved it got a field medal or whatever it's called. So, all right, see you in integration by parts. All right, so beard, Thunder. I saw that integration by parts. You did say sharper jawline, but we're gonna draw a beard anyway, so it's not gonna. You know, the beard does a really nice job of hiding my, you know, unsharp jawline. By the way, if you check the stream tags, I'm back to being the best beard on Twitch. Bob DM'd me and was like, you know, I'm probably not going to stream again, so if you want to take the title back, you know. Man, this looks stupid. We're still gonna hopefully have a beard off at some point, but I was like, I'm just gonna take the title back then. So we will get back to the math after this drawing, but since not a specific homework question from chat, I don't mind spending some time on this. This is gonna look terrible too. My thin little mustache. I don't know. Perfect. You think it can be in the margins of a journal somewhere? Take a picture without the glare. Yeah, let me close the blinds. Is it these blinds? Okay, there. I guess right. Oh yeah, underscore. I saw you typing it in that one problem. So someone said that I should make an art channel in the Discord for the things that I draw. Maybe I should actually do that. Oh, Hunter already got that screenshot. If you have no more emote slots, then replace. Ooh, oh, God. Let me see. I might have emote slot. I'm not sure. One second. Okay. So I did just make a Discord channel for it. Let me check out the emote slots though. That Uop could use glasses too? Yeah, you're right, Anders. And if I didn't say hi, then hi. She was old enough to get a Fields Medal. He published his first proof, but it was wrong by the time he fixed the proof. He was too old. You can be too old for a Fields Medal? I didn't know that was possible. I'll draw myself as Walter White. I'm gonna need my 5,000 coffee beans. A quick introduction to cubic curves. Just like in terms of graphing a cubic? Or does cubic curve mean something else? Oh, I didn't know there's a maximum age. Okay, yeah, I don't have any more animated emotes. All right, sorry, I don't have any more static emotes. I only have animated emotes. So I'm gonna have to replace Uwap. Yeah, well, I'll do this. I'm just gonna fix up this emote quick, and then I'll talk about graphing a cubic polynomial. Because I have to make this into a square quickly, so that's just what I'm doing. Fixed size, 267 by 267, let's say. Did that actually take effect? It didn't. Why? No, fixed size. There we go. That's about centered. Crop. Save as. Bigbrain.png. It can just be right there, I guess. Sometimes conic intersections. Oh. For Math Olympiad? Oh, I think you're asking a question that's probably beyond me. Conic intersections plus a straight line? Are you doing Olympiad math? Because that I know nothing about. Like when you asked about like graphing cubics, I was just gonna do a like here's the graph of y equals x cubed, and then here's the graph of like a few okay, no, I don't think I can give you an explanation that'll help you then. Unfortunately. Images, it is square shaped. I specifically, oh my god, it's not square shaped. One second. What are the dimensions of this picture? 255 by 255. So there's something that I can, and I don't particularly know of anyone who does Olympiad math. Oh no, we have another draw redeem. But there is a Math Olympiad Discord that I can at least show you if you want. Because my understanding of cubics is just like what you would learn like in Algebra 2 class or a pre-calc class. A space-time wormhole and someone sticking his head like an ostrich through it? Okay. The emote's taking a minute to upload, I don't know why, but let me, There's this Mathematical Olympiads Discord. I haven't looked through it much, but it does exist, and it's a pretty big one. So, they do seem to get a little crazy. Like, I wouldn't necessarily call it, like, family-friendly, but, I think this is the best thing that I could, like, tell you about. Can I just get an invite link? You're on it? Okay. In that case, I don't think I have anything for you. Sorry. Oh no, what did I do? Did it not go through? Yeah, like I can't even think of someone who necessarily even does Olympiad math to like refer you to over on Twitch. Oh my god. This freaking thing is 255 by 254 pixels now. Why? This is the pain of making emotes. We'll crop it at 254 by 254. Let's hope this works. Actually, no, let's do 253 by 253, and hopefully that actually doesn't do something weird when I go to save it. Okay, 253 by 253. Save as that. Yes. Now, is the image still 253 by 253? Yes. Now, is Twitch going to hate me when I try to upload it? Okay, finally. Big brain. Upload. And then switching out UWAP. Remove from slot. Okay, it is officially uploaded. Big brain. All right, see ya, experienced water eater. Oh shoot, I know you're leaving, but there are other math streamers out there. I can't recommend anything in particular for Olympiad math, but if you're interested in math streams in general, that is a whole list of them. Sorry that it's like right at the last second, but I wonder if new people come in and like to try to shout them out. You're going to sleep too, Yanis? All right, thanks for hanging out. We've got another drawing to do now. There it is. I mean, it is pretty late for you, so I don't blame you. Yeah, we have not gotten. Man, the one time you're here, I do barely any algebra. Or not the one time you're here, but oh well, you're gonna go as well. Geez, all right, everyone's out. Well, thank you for hanging out and for the Redeem Thunder. We got another one from Anders, and then either do algebra or go back into looking at floating point arithmetic. A space-time wormhole, so someone's thinking his head like an ostrich through it. Okay. A space-time wormhole. That should be blue. I mean, honestly, I kind of want to just draw like the portal, like from the game Portal. Like draw a blue portal and an orange portal, but you said a space-time wormhole, so I'll try to make it like space-time wormhole. Kind of looks like a spider. Okay, so that's one of the wormholes. Then there'll be a math you need to get on top of some Greek mountains or something. Yeah. Draw the other one over here. Then they're sticking their head through it like an ostrich. Man, this black marker is dying on me. Okay, this person has to... I'm gonna draw green. They're like their arms are like holding him back, and then their like neck is. Oh, that's a bit of a long neck though. Let's get the perspective a bit better. I guess he'd be worried about it. Maybe you should be more like looking around. Like he's like exploring. Now let's repair the wormhole. What am I listening to? Where's the space-time? How do I draw space-time? Oh wait, like one end of him should be young, the other end should be old? Oh, Nate. This is I promise I usually do math, but yeah, you caught me at a weird time. I have this channel pointer game where people can make me draw stuff, and we had two of them come in, so I'm flexing my art skills. But I was trying to do some floating point math over on the right side of the whiteboard, but before I was failing at it, but I was trying. Welcome in though. Check out the Discord. Okay, connected by two planes connected by a cylinder. You draw space-time the same way you draw any four-dimensional thing, very carefully. Oh. Oh, and critical. I do have a hard cutoff for the stream today. Shoot, what time is the thing that I'm gonna do? I think it's in an hour and a half. Yeah. So I'm gonna stream up in like an hour plus a bit at the latest. I think we're gonna have to redraw this then. Okay, two planes connected by a cylinder. And then we'll have to get the movie. Oh yeah, I've heard of it. What? I just got up. Why? Oh, okay. Do you don't have anything else to say, Anders? Okay. That's kind of funny though. Every time I get up, just like do the hey, what's something again? Okay. You know, I'm such a gifted artist. I'm sure I can draw this with great ease. I'm already lost on the perspective. Okay, wait. Let me take a harder look at the Discord picture. I literally drew one curve and I was lost. Okay. Huh. Okay. It needs to cross over. And then, okay, this is good. Already, we're up to a great start. Sure. And you know, Anders, in that second picture, I feel like the artist just added a star in the middle because it would look cool. And I'm gonna do the same exact thing. I don't know why there's a giant source of light in the middle. Okay, we'll do the middle in orange. It looks like an egg yolk, but you know. That looks terrible, but you know, I did it. And now we need a dude sticking his head through like an ostrich. So he's gonna... Okay, he's gonna be at the top. Those are his arms. Sure. We're gonna get some spaghettification. The perspective here is just gonna be bad, and that's just not gonna be my problem. Wait, that's the wrong direction for the eyebrow. It's an angry eyebrow. I don't know. It's a really long neck, but you know, I feel like space-time does that. You know, space-time is dangerous. Ovation, thank you, Anders. You know, let me, since I made the Discord art channel, let me take a screenshot of that too. Give me 1 second. Dude, of course, like, today is the day when we get a couple of, like, new people popping in. I guess this is as good of an introduction to stream as I can hope for, though. Not actually doing math. Okay. Got a screenshot. Oh no, I accepted. Can I see the history? No? Okay, that's cool, bro. It was pretty recent. I'm gonna scroll up in chat. Okay, there. Posted it to the Discord. Okay, so Critical did ask a question, I think. Let me see if I can find it. Ooh, eccentricity. I'm gonna have to Google this. What? Oh, why did it open in a new tab? Okay. Go away? Okay. So we want the eccentricity of this polar curve, identify the conic, the directrix, and sketch the conic. I thought directrix was a parabola thing. These are all those weird polar coordinate terms that I just don't know. I think Paul goes over these, though. Come on, Paul, don't fail me now. Identify the conic. I don't know how we're gonna do that. I assume we have like a menu of choices that we have to choose. Does Paul not do this? I guess Paul doesn't do it. Polar coordinates eccentricity. Oh, is this gonna be an ellipse or something? I'm just gonna graph this. Nine over 6 plus 2 cosine theta. R equals 9 over 6 plus 2 cosine theta. Oh. I think that is an ellipse. It's just nearly a circle. Oh, you know, I've looked at the eccentricity before, I think. Okay. The directrix is a distance d away. Constant theta is 0, depends on the direction of the directrix. So I think it's just gonna be matching these, the ED in the numerator and the E down here to the equation that we're given. We have to do a bit of work before that, though. Let me look at a second source just to make sure I'm not going to say the wrong thing. And I think based off those 2 pieces of information, you can just tell if it's what type of conic section you're going to have. I want to see if there's like a rule. Green Marker, thanks for the follow. Oh, you were number 700. Thank you even more for the follow. Oh, hey, here we go. Okay, so if e is between 0 and 1, it's an ellipse. If it's equal to 1, it's a parabola. If it's greater than 1, it's a hyperbola. Okay. For a conic with a focus at the origin. So we do have to notice that there's a 1 here in the denominator, but we have a 6 here, so we're gonna have to deal with that. The term "if the directrix" kind of throws me off, but I think what I'm gonna say here is right. Okay, let's do green. So we have, actually, let me get this in the corner. There we go. 9 over 6 plus 2 cosine theta. Okay, so first things first, I want to factor the 6 out so that this becomes a 1 in the denominator. I want to do anything I have to do to force it to match the format. And now I'm going to bring this 6 up here in the numerator just to make it hopefully more clear what's happening. It's going to look a little weird though. So 9 over 6 is the same as 3 over 2. So we have 3 over 2 over 1 plus 1/3 cosine theta. And I'm writing in such a strange way because we're given this general form of r equals ed over 1 plus e cosine theta, I believe. Make sure I got that part right. Yeah. Plus or minus, but and so here we have the plus case, but I think from here, like once we have it in this format, we can correlate these formulas with each other like directly. So we know this e alone is 1/3. And in the numerator, e times d is 3 over 2. So this is like a system of equations, except we're just kind of given one of the unknowns for free. So if we know that e is already 1/3, let's plug it in down here. So 1/3 d equals 3 over 2. Multiply each side by 3, and you get d equals 9 over 2. So I'd say that our eccentricity here is 1/3, and the directrix is x equals 9 over 2. And because your eccentricity is between 0 and 1, it's an ellipse. I think that's what they want from you for this problem. But again, like I don't know if I've said before, but I don't use these concepts all the time. So if something, if the formula that I said doesn't match yours, you might want to tell me. The answer for the directrix is 9 over 2. Oh, they didn't ask for the, oh no, they, well, so they want, I guess, 4 things. They want the eccentricity, for you to say what type of conic, what the directrix is, and the sketch. So I've answered eccentricity is 1/3. Identifying it is an ellipse, and the directrix is x equals 9 over 2. The sketch part I did not do. Which I don't know how to sketch things from the eccentricity and directrix. I might be able to figure it out though. Yeah. Um, Graphing an ellipse in polar form. So they just plot a few key points here, which I would definitely favor, but I want to see if there's like a trick that we can use. No, they just plot points. Okay, well, we know that's going to be an ellipse, which is a huge help. Kind of interesting, they don't print the foci. I guess we're given one of them is at the origin. Okay. I guess our sketch is going to be an ellipse, and the directrix, it will help us knowing what direction our ellipse goes. So actually over here, I'm going to do a chart. I'm going to plug values into this for theta and find out what r is. So for theta, I'm going to say 0, pi over 2. These are just the normal angles that I always try. And if I need more, I add more later on. When theta equals 0, cosine of theta, or cosine of 0 is 1. So we get 9 over 6 plus 2 is 9 over 8. Cosine of pi over 2 is 0. So we get 9 over 6 is 3 over 2. Pi, cosine of pi is negative 1. So 9 over 6 minus 2 is 9 over 4. Cosine of 3 over pi over 2 is 0, which is 3 over 2. Same as pi over 2. So I come over here to do the graph. Our directrix is x equals 9 over 2, so that's about 4.5. That's exactly 4.5. One of the foci of the parabola ellipse will be at the origin, and the other one is going to be like over to the left. I don't know exactly where. I'm not going to worry about it too much, to be honest. There's this weird mix of Cartesian and polar that I'm not a fan of, but it's like I've already attached some Cartesian coordinates to this, but the actual points that I tried were polar. So when theta is 0, r is 9 over 8. That's just over 1. So at least that means we have a point like right about there, just past 1, when r equals 0. Sorry, when theta equals 0, we go just past x equals 1. When theta equals pi over 2, up here, r is 3 over 2. So that's 1.5. So actually, when you plug in just the 90-degree angles, it's not so bad, I guess. Same with 3 pi over 2. It's just on the y-axis, so you just go 3 over 2 down. And then when theta equals pi, that's the negative x-axis. And 9 over 4 is 2.5. 1, 2, 3. So now you get basically an egg shape. No, it's not an egg shape. It's just an ellipse. It's nearly circular, just a little not. Donda's drawing needs to be a thing. Oh God, Kirby inhaling a hamburger? Okay. Yeah, I'm getting a lot of drawing practice in. Oh, you get the 9 over 8? Okay. So yeah, trying to do like pi over 4 as an angle here would get kind of tricky with figuring out what the radius is. But if you keep your angles to like 0, pi over 2, like, 90 degrees and multiples of 90 degrees, it's relatively easy to do the conversion to Cartesian. But yeah, I guess even knowing the eccentricity and directrix don't help you that much to sketch it. You still have to plug in points. At least for Kirby inhaling a hamburger, I have a better idea what to do with that than man sticking his head through a space-time wormhole like an ostrich. So yeah, critical. Unless you have any questions on that, I'm gonna go do Zach's drawing, and then it sounded like you said you're gonna have a lot of them, so I can come back to you after. Oh yeah, I already see you posted a second one. Okay. What time is it? 3:40? Okay, it's about time. So Kirby, I don't have a pink marker. I guess red is the best that I can do. But then Kirby's shoes won't be a different color. We can do an orange Kirby. Isn't there like, there's different colors of Kirby's in some of the Kirby games, right? But you didn't say Kirby specifically. I'm going to do an orange Kirby because that's just, I want Kirby to still have red shoes. Then the burgers can be the same color. Dude, I need more colors. That's the conclusion here. Okay, we'll do red Kirby. Then Kirby has like the big old. I'm trying to. I think I'm gonna get the like how Kirby like changes in like vacuum mode wrong, but oh, my black marker is basically dead. I shouldn't even try to use it. We'll give Kirby blue eyes, even though it's not right either. They look like ears, but those are supposed to be like, I think his arms go up. Could get sidewalk chalk in a chalkboard? No, I can't. No can do. Okay. Then we'll have some action lines for like the vacuuming. And then I wanted to do orange for the burger buns. And I guess we'll, oh man, what am I gonna do for the patty? Maybe red? The burger looks a little raw, but I'm sure Kirby's stomach can handle it. Put some lettuce on it. Making me hungry. All right, that could look worse. I feel like Kirby would need to be colored in, but that's going to take a crap load of ink. We can color in Kirby's shoes. That just makes it look a bit better, I think. I guess, does Kirby wear shoes, or is that just Kirby's feet? I don't actually know. There's a lot of Kirby lore that I don't know, apparently. I don't know, how's that? Let me check chat. Kirby and have a stomach? I don't know. I can pop that, sure, Blagby. Let me take a screenshot, though. Oh, you're polygon? It sounds like you're happy with it. I'm not sure what else to do with it, to be honest, so I'm glad. Kirby inhaling a hamburger. All right, there we go. Thank you for the redeem. All right, so let me look at Platywe's plot, and then we'll look at Critical's next question. Wait, oh, -1 cubed. Okay, let me get the -1 in there. There's a line break at an unfortunate spot there. Oh, it's the heart! I didn't recognize it. Someone showed this to me before, though. Thank you, Bladwee. It's a nice one. You know, I feel like you can make a cool animation with this, too. Oh, that looks weird. I don't know about that. I was trying to scale it up and down so it looks like it's beating. That's not having the effect that I want, though. If I put an A just like inside there, oh my god, what is that? Whoa! Dude. Alright. But thank you, Bladwee. Let me see what Critical posted. How much more time? Okay, good. I feel like I'm gonna forget when it's time for me that I have to like close the stream. That's why I keep on checking it. But I still have like, I'm still good to go for a while. One of the whole thing, x by x over a. Oh, really? Okay, that makes sense. Test the series for absolute convergence. Ooh. Ooh. Okay, so let me take you through my thought process here. Instantly, I see a factorial, which means taking the limit is usually out. Like, I wouldn't do the test for divergence here because... Actually, okay, let me just show the alternating series test because that's all... that's really what it is rather than the divergence test. So the issue with the alternating series test here is you have to take the limit. This is an alternating series, but you have to take the limit as b sub n, or as the sequence goes to infinity. And taking the limit of 3 to the n over 2n plus 1 factorial, it's kind of tricky. I don't know how I would do it. Because you get infinity over infinity, and it's... applying L'Hopital's to this would be very messy. Or it'd be outside the scope of your normal calculus class. So I guess I should back up even further. As soon as you see the -1 to the n, you should think alternating series tests. That's usually the easiest thing to do. Here, it's still not so easy. So I want to move on to the ratio test or the root test. And the root test only really works if like everything is to the power of n. Not necessarily, that's not necessarily true, but the root test is generally rare. I would much rather try the ratio test every time, and if that fails, then I'll think about the root test usually. Unless I really recognize some easy cancellation or some kind of version of the limit definition of E. That's the only times where I jump straight to the root test, really. Yeah, if the series converges, absolutely. You can throw away the minus sign. The alternating version certainly converges also. But I think the ratio test is going to do... Oh, you don't have the ratio test, do you? Oh, no. Shoot. Yeah, we're just talking about how you don't have the ratio test. Critical. Okay. I think we need to look at the non-alternating series and hope that that's a convergent series. Because if it should be, because I think factorial is much stronger than exponents. But there is a theorem that says if the absolute value of the series converges, then so does the alternating version of that series. And so we can kind of throw away the -1 to the n for the purposes of this problem. Now, how do we prove convergence here? Oh wait, they say test it for absolute convergence. Oh my god. I'm not reading questions all the way through, evidently. That's the second one from Critical that I stopped after I saw the series. For absolute convergence. Okay. How do we do this without the ratio test? Or the root test? I don't think the root test will even help anyway. We have a factorial, so I think... What do I think? I don't think anything. How do we deal with a factorial when we don't have ratio tests? Because the ratio test will just annihilate that for us. Like, it get rid of factorial and be very nice. Ratio test? Well, you don't know the ratio test, though. I mean, I can show how it works. I just would hate to use something you're not allowed to use for the... I mean, if you want to integrate that, you need the gamma function. Problems are final prep. I'll show it to you. Just let me see if there's any kind of like last ditch thing that I can try. You can show 3/4 to the n is greater than it. Oh. Wait. Cut out finitely many terms. So if you have n many fourths in the denominator, 2n plus 1 factorial, that's more than n many numbers. That's 2n plus 1 many numbers. Two n plus 1 factorial is much greater than 4 to the n eventually. Huh. One over a bigger number is small. Okay. Yeah, I guess I was getting things backwards, where, yeah, the factorial is greater than the exponential, but we have 1 over each of them. Okay. Okay, so that's how you do it without the ratio test. I can show you the ratio test too, critical, but... I would rather show you this way. At least first. Because, like, my calculus teacher specifically said no ratio test for a lot of problems. So I don't know what like, at least in the class that I took in high school, like that's what my teacher said. The professors that I had in college weren't as picky. But since I know that teachers can be picky about it, that's why I don't like showing you something that you're potentially not supposed to use for this problem. Who needs the ratio test? I mean, I think the ratio test is much more practical for this problem, but you're right, we don't actually need it. It's much more practical for, like, a student just learning this for the first time, because it's much more plugging things in and doing things procedurally. So our given series is n equals 0 to infinity minus 1 to the n times 3 to the n over 2n plus 1 factorial. Okay. And we're testing abs. Oh my gosh, another drawing? Kirby post-burger absorption with their brand new burger powers? Oh no. All right, I'll get to it after this problem. Hey, Moo. So it's almost like sine. Maybe it's some stupid proof involving sine? Oh yeah, it does almost look like sine. Yeah. Like, if the exponent was odd, we'd be right there. And maybe the exponent of the -1 is off as well. No, the exponent, I don't know. Yeah, there might be, you're right, there might be some weird sine thing that you can do, but actually, I doubt critical has Taylor series yet either. So anyway, the idea that Zachary eats the Twipie put in chat is, it's, I'm just going to say what the answer is, and then I'll explain it, I guess. We're going to use comparison test, and we're going to make the claim... Actually, I'm sorry, we're looking at the absolute convergence. Let me draw a new line. We're going to make a claim that this series is less than or equal to 3 over 4 to the n. For some n starting point. I specifically didn't write that first n index because I don't know exactly when this is going to happen. The idea here is that 3 over 4 to the n is a geometric series that we know converges. 3 over 4 to the n is the same as 3 to the n over 4 to the n. So the numerators are the same, and we just have to compare the denominators, 2n plus 1 factorial and 4n. So we suspect that this initial series converges. We're interested in finding a series that is greater than it that also converges, so the comparison test applies. So what we want to show is that 3 over 4 to the n is greater than 3 to the n over 2n plus 1. Now, how rigorously you need to prove this kind of varies. But if we're comparing 2n plus 1 factorial and 4 to the n, I want to write, greater than or less than sign here. The exact value where this happens isn't necessarily important, but I think the point is that 4 to the n looks something like that, and 2n plus 1 factorial looks something like that. So after wherever this crossover point is, 2n plus 1 factorial is greater. For the sake of your normal calculus class, you probably don't need to know the actual point where that happens, or you don't necessarily need to show it. It's usually good enough that factorial generally increases much faster than exponentials. So after some point n. I would say after, that's supposed to say after some point, but I didn't write it very well. So if you take this you take this and flip it, so that way it's more related to the problem that we have. 1 over 2n plus 1 factorial. You flip the inequality over 4 to the n. Now you just multiply each side by 3 to the n, because that doesn't affect our inequality. So if you're willing to accept the kind of sketchy justification I provided up here, we've kind of proven the thing that we want to prove, that each term has a desired relationship, so their sum should also have the desired relationship. Oh gosh, Enigma. It's 3 math streamers? Okay. Recommend n equals 2. Yeah, so I mean, we probably don't need to know the exact spot where this happens, as long as we're reasonably sure that it does happen. But I'd say by this point, like, we can apply the comparison test and say that it converges. 4 was chosen very specifically as a number that would give us a rate less than 1 for the geometric series. You could also have chosen 5, 6, 7, 8, anything that's 4 or more, or you can even choose 3.5, but why would you? Three over pi to the n? It is. If you want to be difficult. What test did you use? Are you asking, like, this is the comparison test. I didn't actually write it, but the justification that's on the board is comparison test. That's 1 to the n, Padwe says. Yeah, because 3 over pi is 1. Everyone knows it. That's the limit comparison test. I did just comparison. Oh, it's cinch? Huh. So yeah, who said that it looks like sine? Oh yeah, Moose said it looks a lot like the power series for sine. It would make sense if it was cinch as well. Here we go. Actually, I mean, okay, so let me say the limit comparison test is this thing where you set up the ratio and take the limit as n goes to infinity. We did not do that here. We did just the comparison test. And the idea of the comparison test is if you have to suspect the series either converges or diverges. If you suspect it converges, you name a series that's bigger that also converges. And it's almost like the squeeze theorem, like with limits. If there's a series that bigger and converges, that series that's smaller has to also converge. If you think the initial series diverges, you name a series that's less than it and diverges. And that means the series that's greater has to also diverge. So we applied the comparison test here for convergent. So if cosine or sine are involved in the series, comparison test is basically always your best bet. The negative one to the end part, I would say not necessarily in general. They're saying specifically here absolute convergence. So the negative one to the end gets chopped off anyway, and we have to pretend like it's not alternating. Even if it was alternating, it's kind of tricky, and it's actually easier to chop it off anyway and prove absolute convergence. If the negative one is there, you should always try the alternating series test first. And failing that, then you go to other things. Exactly, yeah. And the absolute value of -1 is +1, and 1 to the n is just 1. So when I say chopping off the -1 to the n, that's what's actually happening, what you just wrote there in chat. So, yeah, no problem. I guess we got some drawings to do. I got sorry, I'm just being paranoid about the time. I got another like 30 minutes or so before I want to cut the stream off. Okay, yeah. So I've gotten time zone conversions wrong before, so okay. I got some drawings to do. I can actually no. I'd prefer not to show you the ratio test unless it's like really needed. Okay, so Anders did a redeem for Kirby post-burger absorption with their brand new burger powers. All right, so when Kirby sucks something up, Kirby like looks like that thing. Okay. Kirby becomes a burger. would Kirby's burger power be? Maybe like shooting ketchup out? Spitting little like ketchup balls or something? I don't know. Okay. Kirby's gonna do a little like spitting mouth. I don't think Kirby even like makes that mouth ever, but I'm gonna draw Kirby like that because it makes me laugh. Get to make Kirby look like a burger. There we go. Spitting out little like ketchup balls. That's my pitch for what Kirby's burger power is. Okay. Button hat, exactly. And then Enigma wants a Chimera, except instead of a light bowl and goat, it's 3 math streamers, a red and green belt. Oh, you're right. Okay. Before I move on to Enigmas. Like, I could fill Kirby in looking like a burger. I feel like that's more Kirby-like. Actually, I guess Kirby can solve the button top, though. I feel like the green should maybe go on top. Tomato and lettuce layers. Okay, yeah, we can get a tomato layer in there, too. How's that? You have the green in the hat too? Okay. The hat bigger? Oh god. I'm gonna have to move Kirby's eyes. I guess I can. The things I do for this redeem. Okay. Kirby's eyes look a little weird now, but, you know. You like it? The button needs volume. Alright, let me get a screenshot of this too. And then we'll do enigmas. A chimera of 3 math streamers. Okay. What 3 math streamers should we combine? So it comes out as logical gibberish. It's always fun to draw Pen Center because you can just like put a hat on him and that's Pen Center. Stooky and Dan both have like the distinct hairstyles. Actually, let me look up what a chimera looks like again. Like, how much of a mutant is it? Like, it can have like 5 arms. Oh, I was thinking of this wrong. Okay, so like 3 separate heads. I thought I was going to combine all of them into one. Okay. Well, now I need to like start from the ground up. The human centipede, but with the math streamers, basically. I think, okay, well, when we do 1 body, 3 heads, though, so it won't be exactly a human centipede. We can just add on some arms for fun, though. I mean, it's like there's rules here. Okay. I mean, the blue is kind of dying too. We'll do green. I'm drawing this way too high. I'm not gonna have room for 3 heads here. I'm gonna draw, shoot, where does the chat start? I got room if I do it just above the burger. Already the pants aren't symmetric. The arms. I kind of want to add on a bunch of extra arms because I think it'd be funny. I think I'm gonna make him coming out of the back though, or something. The redeeming person makes the rules? That's true. Does everyone on the whiteboard? Yeah. No more math, just art. Okay, so I think for the 3 math streamers, I'm thinking that like Penn, Stuki, and Dan all have something distinctive about them. No offense, Zach. I like Zach is here, so I want to like include Zach though. I mean, I could do a 4-headed. I don't know. I guess for Zach, like it'd just be glasses though. That's like the best thing that I can like think of. Hmm. Those 3 are great. All right. I guess we'll do orange skin because why not? Maybe they all got spray tans. Okay, so this is something like what I'm going for, but we need to make each of them like distinct, right? So I guess Penn's center. So, you know, center's right in his name. So we can make the middle one Penn. And hopefully the black works well enough to draw. I feel like he usually wears a black hat. Hopefully the black will hold out just enough for that. Yeah, it's already dying for the eyes. I have no idea what color his eyes actually are, but we can just do blue. Oh, then I have to do black hair for both Stuki and Dan. Whoa. Scared me. Abson, thanks so much for the prime. Zach has glasses and a tie and no shoes. Yeah. That's true. Wow, the prime before you follow. Well, thank you so much for both, Abson. God, I forgot I had that as an alert. Okay. I need the black marker to work. I literally have new ink in my Amazon cart. I just need to actually order it. Ah, there's no way, bro. It's kind of working. Not really, though. If I just have it, like, tilted up. Like that. 20 out of 20 sub pipe? Oh, yeah. Thank you especially for that. I mean, okay. While the black marker hopefully, like, feels better, they definitely need to have, like, something in their hands, right? Like, for Dan, we could easily do, like, a Nintendo Switch controller. What color should I make that? I guess blue? I don't remember how it exactly looks. Honestly, that would apply to pen too. Maybe pen could have. I mean, pen's always playing like Ocarina of Time specifically, so we could do like an N64 controller. Then for Stuki. Stuki would have a mug of tea, I feel like. That arm was so misplaced. I was about to draw in. I mean, I don't know if there is a proper place for a third arm, to be fair, but that feels. If I was to have a third arm, I feel like it would be more like that. Hmm. It looks a bit like a beer mug, but it's tea, I swear. You can have red tea, I guess. I don't know why the string and grabber thing is also red. Who controls the legs? I think they have to agree on it. I think it's a democratic process where they each get control of 2/3 of a leg. Yeah, we'll give Pen an N64 controller, I guess. That looks like something else. Let's get the rest of the control. Okay, maybe not an N64 controller. Let's try something else. Okay. He can be holding Reese's leash. How about that? That was gonna look like something else, no matter how hard I tried to draw it. Add a third leg, yeah. Thank you, Zach. Yeah, it was who was it, the 700th? It was Green Marker, I think. Oh god, but now I feel like I have to draw Reese. It's only gonna be a sketch of Reese because this really isn't the point of the drawing, but okay, there. Okay, how does the black marker feel now? Is it feeling better? No, it's not. Okay, well, they're gonna get some crazy hair then. You know, maybe Dan and Suki have always wondered about dyeing their hair. Blue, sure. Okay, how does... Oh my god, blue is also dying. Okay, they want red hair, I'm sure. God, dude. Will I ever stop being lazy and actually order ink? I don't know, like, how to draw Dan's hair the best, to be honest. I'm just gonna do that. Oh god, he's got... Dan's eyes are a little crazy. Conjoined triplets. Then Suki has the poofy hair. I mean, it's more like curly than poofy, but I don't know how to Sure. There we go. I don't know, Enigma. This one got out of control. The important thing is, how do you feel about it, though? I'm not gonna be able to stream for much longer. I guess there's another question that's waiting, though. Because I don't see one in my Discord. Let me make sure. Okay. Oh, wait. Oh, no, okay. Oh, Enigma might not be here. Oh, you are here. Okay, fantastic. All right, I'm glad. That's a hard one. Oh, no, you're good. I just like to make sure I always leave my customers satisfied. Sorry, I was taking a screenshot. I need to take a better screenshot. Okay. I've got like 10 minutes max here for when I close things down. Although I don't really have a question. I don't know if Critical had more. I don't see any more posted in the Discord. I was looking into the floating point addition thing. I could look into that for a bit longer. So I would love to get integration by parts a better answer. I just don't know if I can. Close out a bunch of these tabs. Oh god, yeah, we didn't even necessarily answer Thunder's question completely, did we? And I'm gonna think about that right now, though. Oh, really? Well, so the question came from this is the original question from integration by parts. Both of us were confused on what the both using 2's complement thing actually means in the context of this problem. I think what it means for this problem is that this number down here is negative. I'm not sure of that, though. Quick math, 222 in base 6, that's your understanding? Okay. Choose your integration by parts. I just want to see if I'm going to pull their chat history, because they put the answer in chat. Oh, wait. Oh, did they spell it different? Oh, dang. I had to look through the VOD to get what the answer was. But I think they didn't get the correct answer here. I was getting, because I thought for the mantissa there's an implied leading one that isn't written in storage. But yeah, it's been too long since I've done this. For Anders, 222 in base 6. What's the nearest power of 6? I'm looking for like an easy trick rather than having to like go down the algorithm. 6 times 36 is 6. 6 times 36. So you do 6 times 6 is 18, carry the 1. No, 6 times 6 is 36, carry the 3. Then you get 18. Add 2, you get 216. So it's 101 in base 6, right? Oh, it's 1010. I forgot about the one place. Ah, all right. I was starting my number system from 6 to the 1 rather than 6 to the 0. All right, you get your points back. All right, I kind of want to speedrun my theory for how you do this problem and see if it looks like what the right answer I think was. But I am gonna have to cut off the stream in like just a few minutes here. Wait, 010 100. 010 100. Move the decimal to the right twice. Oh wait, if there is an implied leading 1, that 0 is the sign bit. Not enough time for... Yeah, exactly. I saw you... I followed along for a little bit of you doing that test. And, as soon as I got to, like, the Roman numerals, like CMIX or whatever, I was like, what the hell? I don't know what these mean. And then we got 3 zeros. That one gets moved over once. Then we have negative. One to 3 zeros. That? Or another 0? No, just that. Okay. Oh, wait, but you have to move the decimal to the right twice. Okay, that's my theory for what these numbers are. And if you add them together... Wait. What? When you have 1 plus 1 with a 1 being carried, oh, it's 1 and you carry another 1. Zero, zero, 1, 0, 1, 0. How does subtraction work? Is it like 1, 1, 0? 1? I don't think that's right. I feel like I'm still, I think I'm doing it wrong still. You put it back in mantissa it'd be 0, 1, 1, 0, 0, 0, because you want 6-bit, and then the exponent will be 0, 0, 1, 0. I don't think that was the answer though. I think oh shoot, I'm cutting off the answer. Oh well, I'll think about it more off stream. I'm gonna go raid out though, or see if there's someone on to raid. Saturday nights are always a little hard. because I do have to end the stream. I have to pee so bad. Thanks for hanging out with me, Zach. I'm going to cut the YouTube stream off here, so if you're on YouTube, I appreciate you.